Okay, this is Unit 5, Lesson 7, second semester, 7th grade math. Vocabulary review. An outlier mostly affects the blank of a data set. First of all, who can tell me what an outlier is? Because throughout the day, students have struggled with this. And they have a rough idea of what an outlier is, but I just want to make sure you guys understand what it is. Olu?
It's like when you have a data set and then one number from the data set is like way lower than all the other numbers are higher.
Right. So that's exactly right. You said if you have a data set and there's either a minimum that's way lower than most of the set or a maximum that's way higher than most of the set. So I'll give you an example. Suppose I had a survey and I asked you, how many brothers and sisters do you have? Okay? How many of you have no brothers or sisters? Okay? One brother or sister? Two brothers or sisters? 3, 4, 5, 6, 7, 8, 9, 10. So I don't really have 10 brothers and sisters, but that would be an outlier. But you guys saw that most of the data was between 1 and 3, right? Most of it. So an outlier would have been, in this case, would have been the 10, right? Okay. So an outlier is not necessarily the maximum or the minimum, because those can be close to where most of the data is at. It's a maximum or a minimum that is very, very far away from where most of the data is at. Does that make sense? Okay, so let's take a look. Which of these does it mostly affect, the mean, median, or mode? Nathan? It affects mostly the mean, know that. Hint, hint, you're going to see that question, okay? The outlier mostly affects the mean of a data set. Okay, now, who can tell me what they got for the median? Jayla? 118, so you arrange it least to greatest. You saw that there is no middle number, so you had to make a middle number. So 17 and 19, you take the average of those two numbers, add them together, divide by 2, you got 118. Okay, the mean, did anybody calculate the mean? What is it? 116.7. I think I got 117. Is that what you guys got? Yeah. I have some people yet nodding yes. Okay. All right. And then what would the mode be? Here's least to greatest. What's the mode? Does anybody remember what the definition of the mode is? What is it, Moyen?
The mode?
Mm-hmm. The mode. 123. 123. And the mode is what? What is the mode?
The number that appears.
The number or numbers that appear the most. Because remember, you have a tie for the most. So you got more than one number. That's the mode. Okay? If there's no mode, what do we put? We don't put 0, right? What do we put?
No mode.
We just say no mode. Okay. Here we go. I made a frequency table. I don't have a row for the tally marks, but you guys can see, here's my frequency table. Are we good? Okay. Easy so far, yes? Okay. This lesson goes by pretty quick. Now, take a look at this. I'm going to go ahead and read this since I want to put this on the class channel. What you'll learn: to identify misleading graphs and statistics. Why learn this? A graph can be a powerful way to present data. How you draw a graph can affect the impressions you give about the data. So let's take a look at this graph. How is this graph misleading? Quinn?
The y-axis doesn't start with 0. It starts with 25.
I think you mean yep. It doesn't start at 0. And what does that do? How does it make the bars appear if it doesn't start at 0? It makes them look shorter than they actually are, right? So 4th grade, it looks like they don't study much because it doesn't start at 0. Do you guys understand? So by not starting at 0, it's kind of misleading. Now, there are 2 fixes for this, okay? There's 2 ways we can handle this to fix this graph. Let me go over the 2 ways that you can fix it. Because you're going to be assessed on how graphs are misleading, so you need to be able to identify that. But you also need to be able to say what you got to do to fix it. So here are the ways we fix this. So the graph's misleading. It leads you to think 4th graders don't spend much time doing homework, okay? And redrawing the graph. So let me show you the 2 methods. So the first method, if you take a look, what did I do here? Start at 0. I have the same interval for all my y intervals, right? By 20. And remember, it's okay to have spaces between your bars on a bar graph, but it's not okay to have spaces in between what type of graph? A histogram, very good. Okay, so this is one way to fix it, starting the vertical scale at 0. The other way to fix it, I want to share with you, it's called a line break. Okay? And the line break is sort of a way of telling you, like, hey, this does extend down to 0. And sometimes line breaks might even have something like this to show you that, hey, there's a bar in between this that goes all the way to 0. Does that make sense? So let me explain to you what's happening. Suppose, has anybody ever gone to a dock at like a lake or the waterfront? Okay. And you may or may not know how deep the water is at the end of the dock, right? Okay. And suppose you saw something sticking out of the water just next to the end of the dock. Okay. Unless you know how deep that water is, you don't know how tall that thing sticking out of the water is. Does that make sense? And so let's say you're looking at it and it looks like this stick is, or whatever it is sticking out of the water about a foot. Okay? But you have no idea how tall this is because you don't know how deep this water is. But then you find a sign that says the depth of the water at the end of the dock is 10 feet. So what can you conclude about the height of that object sticking out of the water? 11. It's 11 feet, right? Okay? So that's kind of what we're doing here with this line break. We're saying, hey, look, this is what you see sticking out because what's most important is right here at the top, and there's quite a bit below the surface. Do you guys understand? That line break would be like the water surface. And you'd need to understand that below the water surface, there's some depth there. But the only thing that you're interested in is what you see above. Does that make sense? It's so that you understand that any bar that's like just above or within the window of the graph, it extends below that. Okay? Now, why do we do that? I'm going to show you why. Here's why. When a break in a vertical scale is especially useful, okay, when is a break in a vertical scale especially useful? When space is limited, okay, because if I was to draw something that, you know, had a really long, tall bar, right? I could address that with a scale, or I can address that with a line break. Okay. Another reason why I use it. Here, our difference from one grade level to the next is about 10 minutes, right? But let's just say we were comparing bar graphs where the difference wasn't so much. Let's say the difference was maybe a minute, 2 minutes, 3 minutes, right? So if our scale wasn't right, it would look like our bars are almost even. Does that make sense? So we'd want to zoom in, right? And maybe decrease the intervals between the scales, and then you'd have a line break to show just that part. Do you understand? Okay. So, Kalila.
Did you do this for let's say 0 and a number like 100, and then if like it just started like 120?
Well, you want to make sure that wherever you start it.
Pardon the interruption, teachers and students. We are now complete with park testing for the day. 8th grade students, you will now transition into your 5th period classes and resume our regular schedule.
Wherever you include the line break, you need to make sure you're including the top of each of the bars. You can't put a line break in and chop off and not have a bar. Does that make sense? Okay, are we good? All right, so next part of the lesson. Now take a look at this. More misleading data. Graphs can also mislead if the vertical or horizontal axes have unequal or very large intervals. Example, misleading intervals. Profit. Marketers use the graph to show investors that annual profits increase steadily. Explain why the graph is misleading. Why is this graph misleading? Why is it misleading? Well, if we look at this, what type of function is this? A linear function. But is it really a linear function? A linear function means there's a constant rate of change throughout the entire graph, right? But can we conclude that? The graph looks that way, but can we conclude that? No, why not? A day. Joshua? Look at this. The first interval on the x-axis is 5 years. And then it goes from 5 to 15. That's 10 years. And then it goes from 15 to 30, that's 15 years. So really what's happening is it's not a linear function. The rate of change, the rate of annual profits isn't consistent. It's really steep at first in the first 5 years, and guess what? After that, if I was to redraw this, here's what it looks like. Do you guys understand? Now, what I would do is I'd look at this and say, hey, you know what? In the first 5 years, the profit's pretty good, so I'm going to invest for 5 years and then pull my money out and invest in something else that has the same rate or better. That's as steep or better. Got it? But see how this levels off and it starts to decrease my rate? Okay. Now, let's go ahead and take a look. Here's what the book says about that. The intervals of the horizontal axis are not equal. That's what we just said. The annual profits increase $10,000 in 10 years, and annual profits increase at a slower rate as the intervals are spaced out. Do you guys see that? So that's just what we talked about earlier. Now let's take a look at this. I already did A for you. Take a look at this graph. Yes? After this is done. What's up with this graph? If you look at it, it looks like there's some wild changes, right? But look at the intervals. Are the changes all that wild? Okay, what else is wrong with this? Tori? It doesn't start at 0. We like to start at 0 on bar graphs. On line plots, we don't necessarily have to. At least that's just how the book is. Quinn, what do you have to say about that? If you look at the intervals, we have 2000, and then we have another year between these. These intervals aren't clearly labeled, right? They're spaced out in a way that it makes it look like there's wild swings because of the increments on the y-axis, but it's not clear what every interval is on the x-axis. Laura?
I don't understand how you read through.
I did that above. That was for the example. I redrew this one. But we're going to redraw this one now. How can we fix this one? Well, we need to first address the x-axis. Okay? So what does it look like the intervals are right now? Does it look like they're even intervals? So from 2000 and then halfway between 2000 and 2004 should be what? 2002. So I don't know if that looks right. What kind of what intervals can we use? What interval would you use? Intervals of 2, intervals of 1 year? I'm hearing 1, I'm hearing 2. Can we change these intervals on the number of students? Would you change the intervals on the y-axis? I'm hearing no. Question? Well, we know that halfway between 2000 and 2004 is what? 2002, right? So I'm going to take a wild guess and say that halfway between 2000 and that first interval is what? 2001. So you see how we're going to fix this? Okay. So to answer your question, yes, we do have enough information. Here's the graph. And if you notice when it's redrawn, it doesn't look like things fluctuate so much, does it? Okay? And notice I'm starting my first point at the y-axis, and then we could track the growth from there. Okay? So for the bar graph, yes, you want to show 0 somewhere, but for a scatter plot, at least the examples the book provides, you don't necessarily have to. All right, so guess what? You want a pet. You don't have a pet, you want a pet, and you're trying to convince your parents to buy you a pet. Actually, you're not trying to convince your parents to buy you a pet. You're trying to convince your parents to buy you 4 pets. So use the mean, median, or mode of a data set to inform or mislead. So guess what? You're going to use the mean, median, or mode, one of those, to inform or mislead your parents about the data you collected from the students in your class who have pets, who do not have pets. So, you took a survey. It should be an unbiased survey, by the way. You survey students in your class to find the number of pets per student. The results are shown. You want to convince your parents to let you have 4 pets. Which measure of data should you use? Mean, median, mode, or range? I'm hearing mean. Does anybody disagree? Joshua, what do you think? You think the range? Who agrees with him on range? Nathan? Who's got a different answer? What's your answer? When we're done with this. What's the answer? Does somebody have a different answer? So I've heard mean, I've heard range. Why not mode? What's the mode? 1. Is that going to help you convince your parents to get you 4 pets? No, the mode's not right. What about median? What's the median? Is there a middle number? No, there's not a middle number. I have 2 numbers in the middle, and I have to take the average of those 2 numbers, so my median's going to be what? 1.5. My mode, we saw, was 1. What's my range? 27. My range is 27. Is that going to help me convince my parents to get 4 pets? Yes. They're going to look at you and say, I don't care how many pets they have. They could have 100 pets. I'm not getting you a pet. So that might be a little bit too extreme. So what's left is the mean, and here's the calculation for the mean. The mean is 4 pets, okay? Be ready to pick out the one that helps you mislead to what you want, okay? You want to mislead or convince somebody, so you're going to choose mean, median, mode, maybe range to convince somebody that, hey, this is what the data says. You might leave out some of the data, but pick the one that you want. Come on, you guys are, have you ever been in trouble and you only gave some of the details? You didn't want to lie to your parents necessarily, but you didn't tell them everything. Okay. All right, well, that's nothing new, especially when it comes to advertising. Okay? And we're going to see in a minute. Okay, moving along. Which 2 values would you consider to be outliers? 27. Which 2 values? 27 and 15. Very good. Now, moving along. Take a look at this advertisement. You can mislead by showing part of the data or leaving out facts. Okay? Below are data about Harry's Hamburgers. Is the advertisement for Harry's Hamburger Land misleading? Yes. Look at it. It says Harry's Hamburger Land, home of the under 500 calorie burger. Is that misleading? Why do you say it's definitely? Because most of them are above that, right? So, if you notice, yes, correct, what you said, yeah, there's only one hamburger that's less than 500. How do you rewrite the poster? Now, you can't change the data. You have to use the data. Look, there are businesses out there that have lawyers and say, no, that's false advertising, you're getting in trouble. You still have to state the facts. Don't change the data, but change the poster so that it's not misleading. Give me some examples. Well, you still want people to think that what they're eating is like not going to completely clog their arteries. So, raise your hand. I can only hear one person speak at a time. Taylor.
Home of the under 60 grams of fat.
Okay. I think we can do a little bit better than that. Home of the under 60 grams of fat. Okay, let's try to keep using calories though. Let's try not to switch columns. Just try to keep using calories. What can we say about calories that we can keep using for our advertising, but is not misleading.
One less 500-calorie burger.
Home of the under 701 calorie burger.
Okay. I already heard that. Jameson, do you have an answer?
Home of the under 100 grams of fat burger.
No, stick with calories.
Okay, fine. Home of the under 800 calorie burger.
Okay. Look, let me show you. Let me show you a way that this is what the book gives as an answer. So maybe you guys will understand. Here's how you fix it. The easy fix, the first easy fix is you're clear about which burger you're talking about.
But at the same time, if you don't get a kitty burger,
Right, but now it's clear. The only burger that's under 500 calories is the kitty burger. Now, what other way can we fix this? Maybe this will give you a hint on another way.
Mary's hamburger man. Almost diabetes.
not all of our burgers are over 700 calories.
You don't have to use the same name if you don't want.
Home of the health burger.
There you go. Home of the health burger. What else can we add into that? Home of the health burger. How many calories is that underneath?
500.
I like what somebody just said. Home of the under 600 calorie health burger. Okay, shh. Almost done. Use the graph at the right. Shh. Does the vertical scale start at 0? No. Misleading. Are there equal intervals used on both the horizontal and vertical axes? No. Misleading. The graph makes the price change seem greater or less than it really is.
Yes.
Greater or less? So the price of widgets, because we're not using the same intervals, it's making it look like there are bigger changes from one year to the next, right? So it's actually greater. Okay, and then the last thing I did, but we're not going to do today because we're short on time, redraw the graph so it does not mislead. What do we have to change so it's not misleading? Start at 0, equal intervals, okay?